Welcome back to lesson 9D. In the next preview assignment and in the next class, you will need to be able to create a scatter plot and generate a trend line using technology. First, we're going to talk about creating a scatter plot. There is an article, Clearing Up Confusion Between Correlation and Causation. It has several examples where there is a correlation between two types of data. It analyzes if one value causes the other. We will be creating a scatter plot using one of the data sets from this article. The following data comes from the article Clearing Up Confusion Between Correlation and Causation from the website Conversation. To look at the data before we start answering questions, the first part includes number of people drowned by falling into a swimming pool and the number of films Nicolas Cage appeared in. We have different dates. And so in the year 1999, 109 people drowned. Nicolas Cage was in 2 films, etc. All the way to 2009, 102 drowned and 4 films where Nicolas Cage appeared. If you haven't already hit pause to complete question 1, this is a good time to go do so. Then come back and we'll work on it together. Part A asks, when you create the scatter plot, which variable should be on the vertical axis and which should be on the horizontal? Explain. So the whole time I've been talking to you guys, I keep saying it makes much more sense to me when I can see it somehow. And so it's asking which one of these, the years, the number of people who drowned, or the films that Nicolas Cage appeared in, should be on the vertical axis and which should be on the horizontal. Quick reminder of what we're talking about here, whether there's any kind of correlation or not, and whether we can imply causation. And so we're not going to use the years. We're trying to ask, are the drownings causing, or is there a correlation between drownings and the number of films Nicolas Cage is in, or are the number of films Nicolas Cage is in going to imply, impact, cause the number of drownings by falling into a swimming pool? So either way is going to be fine. And part A, it doesn't matter. When we look at part B, it says enter the data into a spreadsheet, use column A for the year, B for the Cage films, and C for the number of drownings. And then part C says create a scatter plot, and for ease of answers, let's just make sure the horizontal are the Nicolas Cage films. So we're going to put Nicolas Cage on the horizontal. Like if he was in 2 films, then how many drownings were there? If he was in 3 films, then how many drownings were there? And so I'm going to go to the Excel spreadsheet now. So here's a spreadsheet as we discussed earlier. The year is in column A, the number of films for Nicolas Cage in B, and in C, the number of people who drowned, and it all goes with that year. So it's asking us to create a scatter plot. And so I'm going to grab both of these columns, and I'm going to hit Insert and Scatter. And we get this with an interesting title and no titles on the sides. So let's go ahead and clean this up just a little bit. Like for a title, I'm going to get rid of those words, and this is a scatter plot for films and drownings. If I highlight over here, wait, get my plus, I can tell that I want some axes titles. We'll go with axes titles, and over here on the vertical, the number of drownings. And on the horizontal, let's do number of films. So this looks much better. We're going to go on to work question 2, and then we're going to come back to this on question 3 and look at some more parts, but we're going to go do some stuff by hand and then come compare it to what we get or calculate in Excel. So if you haven't already done question 2, I need you to hit pause, go work on it by yourself or in a small group or with a tutor, and then come back and we can work on it together. We know from worksheet 8D that spreadsheets and other technology can place trend lines on graphs and generate equations for those trend lines. But it's also possible to estimate the equation for a trend line by, number one, picking two pairs of the data and finding the equation through those through those 2 points. Which pairs we choose will be arbitrary, and that's why the result's going to be an estimate. So part A asks us to write the data from 2003 and 2007 as ordered pairs. Again, I like to go off on the side, and if we've got Nicolas Cage films on the X, and then we have drownings on the Y, that's going to be our ordered pair. Looking at 2003, in 2003, there was one film and 85 drownings. In 2007, there were 4 films and 123 drownings. Part B says calculate the slope, round your answer to the nearest hundredth. So hopefully by now you're starting to get into a rut, if you will, that when someone says slope, you label your points, you write out the entire slope formula, and then you take off filling in pieces and parts in the blanks. 123 minus 85, 4 minus 1. It asks us to, right there, round to the nearest hundredth and see a resource if we need some help. And this is in your My Math Lab book. I'm going to do 123 minus 85. I get 38 over 3. When I divide 38 by 3, I get about 12.6 repeating, and to the nearest hundredth will put us at 12.67. And so I do want to go ahead and use some words, and some words would be whatever's in our Y are the drownings. So this slope is saying there are about an increase of 12 drownings for every one film that Nicolas Cage is in. Another part that needs to kind of become where it's getting rote or just automatic is when we're talking about that we're going to need an equation. The equation y equals mx plus b is on standby. You just calculated the slope, and so we need a y-intercept. So looking down here at part C, use either point, because this is an estimate from part A to calculate the y-intercept, and refer back to what we have already done to calculate this. So looking at this, I'm going to go ahead and write down y equals mx plus b. I'm going to be a little lazy here, and I'm going to pick the smallest point that we have. And the smallest point is this one. It does not matter which. It says use either. And so I'm going to put my y here, my slope value here, my x here, and b here. I'm going to subtract this 12.67, because times 1, it's still 12.67, from both sides, and my intercept is going to be whatever 85 minus 12 and 67 hundredths is. Starting all over, 85 minus 12.67. And so we're finding out that our y-intercept is 72 and 33 hundredths. Part D is on another slide. I want to go ahead and put it here because our data is here. Y equals mx plus b is the formula. And we're now going to plug in the two pieces we have calculated. We calculated the slope, 12 and 67 hundredths x, plus we now know an estimated slope and y-intercept. So I want you to circle these, highlight these. We're now going to go calculate the trend line of best fit using Excel, and we're going to come back and compare what we did by hand to what we have through a computer using more than our few points that we used. So looking at question 3, if you have not paused and worked on question 3 by yourself, now's the time to do it, and then come back and we can work on it together. Now we're going to use a spreadsheet. We're going to plot and then look at the equation for the trend line. This talks more about regression, and however, if all we want is the equation, then the spreadsheet can do this for us. Here is some help, either in Excel, Numbers, or Google Sheets. And you can always search the internet for more. But we're going to move on to part A that says, find the equation of the trend line from the scatter plot we generated in question 1 and write this down. So I'm back at the Excel spreadsheet. I'm back at our chart scatter plot that we made. And even looking at it, it appears that it's linear. It appears that it's going up a little bit. But let's find out. I'm going to click on the plus, and I'm going to go down here to trend line. It draws the trend line, but I want to click on linear, more options, and scroll down. I want to display the equation, and I don't think we want r or r squared. We just want the equation, so I'm going to leave it at that. And looking at the equation, I want us to write this down. And I'm going to have to write it down over here on the side. So I just wrote down the information here. The slope is 5.8, and it's going up. And so it's indicating that there are about 5.8 more drownings for every one film that Nicolas Cage is in. And then the 87, if we went all the way back over here to the y-axis, then it says that we would have a y-intercept of around 87. I'm going to go grab, let's see if I can just get it this way. Nope, it's here. Nope, it's not that one. It's this one. So I want to go back to where we did this by hand, and let's look at some comparisons. We just saw that the computer said that our slope would be, let me find a different color. I've used a bunch of colors. It said that our slope, when we just looked at the calculation, it said our slope is about, on the calculation, 5.8. We got 12. And so I'm looking at question 3, part A. It says find the equation in the trend line. So I've written those down on my paper over here. And then it says, what is the slope of the trend line from the scatter plot? And it says the slope is about 5.8. That's question part B. And it says part C is the slope close to the one we calculated. And well, no, it's not close. But they're both positive. They're both going in the upward direction, but they are not close. And then part D says, what is the y-intercept of the trend line from the scatter plot? And so on our scatter plot, we got about 87. And so it says, excuse me. So this is our y-intercept. And then on E, it says, is the y-intercept close to what we estimated? And well, they got 87, we got 72. That's not really too far off, but theirs is higher than what ours is. Then the final part on question 3 on part F says give a possible explanation for the discrepancy between the results of our manual calculations in question 2 and the computer calculations. And one thing to think about is our manual calculation used 2 arbitrarily chosen points, just 2. And the computer used precise calculations to find the equation of the one line that fits the data best. We just picked 2 old points and then started calculations from there. The computer looked at what is the very best line and used points off of the very best line. If you have not answered questions 4 and 5, this is the time to go answer both of them and then come back and we'll finish up this lesson. From the scatter plot on question 4, does it appear that the number of Nicolas Cage films is correlated with the number of drownings? And if you just looked at this and didn't use reasonableness or think about it, you would look at it and think, well, it is going up. It does look like the line looks pretty good, but when you think about it, the number of films that Nicolas Cage appears in is going to have nothing remotely close to the number of drownings in our scatter plot. So it does look like there is a correlation, but on question 5, is it reasonable to think that Nicolas Cage films cause the drownings? And the answer is definitely no. This finishes our lesson 9D. You need to look at your syllabus to see if you have more to complete this week and upload by our deadline. And so get onto those if you need to, and if not, finish up information for this week and upload all your pages to D2L in a batch. We'll see you later.